Good morning, students. I hope all of you are safe at home. And yesterday I think that you have gone through the video. I hope that all of you have understood and did the calculation part for the PK experiment. Today I am going to demonstrate to you the second instrumentation experiment, that is estimation of FAS potentiometrically using standard potassium dichromate solution. One request to all the students, when you are listening to the video, please keep your manual with you so that you will understand it very well. Okay? So we are determining estimation of amount of FAS. What is FAS? FAS is nothing but ferrous ammonium sulfate. So it is a double salt of ferrous sulfate and ammonium sulfate. If you see the formula of FAS, ferrous sulfate FeSO4, ammonium sulfate NH4 twice SO4, and it is hydrated with 6 water molecules. So it is a double salt of ferrous sulfate and ammonium sulfate. And the other name of FAS is more salt. Okay, now we are going to estimate the amount of FAS present in the given FAS solution using standard potassium dichromate. We are using dichromate solution K2Cr2O7. So when we say reaction between FAS and dichromate, those reactions are called redox reactions. That means as one gets oxidized and other reagent gets reduced. So it is a type of redox reaction. And now before we are proceeding to the experiment, you have to understand what is a potentiometric titration. So potentiometric titration is nothing but we are determining the equivalence point of a redox reaction using a potentiometer by measuring the EMF of the solution. That means in this reaction, FAS reacting with potassium dichromate, where in FAS the iron is in +2 oxidation state, which is getting oxidized from +2 to +3, and the potassium dichromate, where the chromium is in +6 oxidation state, getting reduced to +3 oxidation state. So this redox reaction, for this redox reaction, we are going to determine the equivalence point by measuring the EMF of the solution using a potentiometer. So you have to know again one more word, EMF. EMF is nothing but E cathode minus E anode. All of you know, you have studied Nernst equation. Because this experiment works on the principle of Nernst equation, E is equal to E naught plus 0.591 by n log of Mn plus. You have derived the Nernst equation and you have studied the applications of Nernst equation, which is very important also. So based on that principle, this potentiometer works. Okay. Now coming to the explanation of this instrument, this is the potentiometer, and this potentiometer is connected with two electrodes. One is a calomel electrode which is called as a secondary reference electrode, and another electrode is the platinum electrode which is called as indicator electrode. Please try to understand here. The potentiometer is connected to two electrodes. One is calomel, which is a secondary reference electrode, and this is platinum electrode, which is an indicator electrode. All of you know what is a reference electrode, because whose potential can be determined by using a standard hydrogen electrode. And next you have to know what is an indicator electrode. This electrode is the electrode whose potential depends on the concentration of the ion what we are going to determine in the titration. Okay, this is platinum electrode and this is calomel electrode. So now we will start doing the experiment. Before we are doing the experiment, first we have to wash these two electrodes carefully with the distilled water on all sides. And now take out the beaker containing distilled water. Now you are taking a beaker containing FAS solution. ferrous ammonium sulfate solution. No need to add water. Dip the 2 electrodes in the FeS solution, and now you take a test tube and take a reagent bottle containing sulfuric acid and take sulfuric acid into this one test tube and add the one test tube of sulfuric acid into the FeS solution. Please remember, this is very important step of the reaction. If you won't add sulfuric acid, you will not get the accurate results. I'll tell you why later. So it is very important that you have to add one test tube of sulfuric acid to the given FeS solution before we are doing the titration. Okay. Now after adding sulfuric acid, now we have to shake the solution well once and measure the EMF of the solution. Now it is showing 330 EMF. Okay. Now we are taking a burette, which is a microburette. Again, the capacity of the burette is 25 ml. Filled with potassium dichromate. You can see the orange color. It's potassium dichromate, where the chromium is in +6 oxidation state. And putting downwards, see that the nozzle should be inside the beaker. Now the instrument is ready for doing the experiment. Okay. Now in the manual book, we will take the tabular column to note down the values in the tabular column. Without adding potassium dichromate, the FeS solution is showing a potential EMF of 335. We have noted down. Now we have to add, like yesterday's experiment, the potassium dichromate in 0.5 ml increments, only 0.5 ml increments, and after addition of 0.5 ml increments, you have to shake the solution well. Redox reaction is occurring where iron is getting oxidized and chromium is getting reduced, and now we have to note down the potential of this EMF is 388. It will increase when you are adding the potassium dichromate. Now again you are going to add again 0.5 ml of dichromate. So you can observe the color change of the solution here. The solution is slowly changing into green color. It is an indication that the redox reaction is occurring. So after shaking the solution, now you have to note down the constant EMF of the solution. It is 406. Now again we are going to add 0.5 ml, that is from 1 to 1.5 ml of potassium dichromate. Again shaking the solution. See the color intensity of the green color is increasing. And now again you will be noting down the EMF 423. And now again you have to add 0.5 ml, that is from 1.5 to 2 ml of dichromate solution. We will be shaking the solution. Should be very careful with the electrodes what we are using inside while we are shaking. Now you will be getting 436. You have to note down. Now again we will be adding the dichromate from 2 to 2.5. Again shaking. And noting down the EMF of the solution. It is 450. Now again we have to add 0.5 ml, that is from 2.5 to 3. Again shaking the solution. It is 458. Again we will be adding 0.5 ml, that is from 3 to 3.5 ml, and shaking the solution. See, the color intensity is increasing, it's becoming thick green now, and now it is 471. It is increasing. 3.5 to 4 I am adding. Again shaking. Now the EMF of the solution is 481. Now again I am adding 0.5 ml, that is from 4 to 4.5. Again shaking. If you won't shake the solution, otherwise the redox reaction will not occur. Now the potential is increasing drastically from 400 to 500. That means we are reaching the equivalence point. It is an indication that the equivalence point is reaching. So now the EMF is 502. Now I am adding from 4.5 to 5. Now see that potential is increasing. It takes time for 424, 25, 26, 28, 29, like that it is increasing. 536. Now